Here we continue our coverage of functions of several variables. This section is a dense one, so I split it up into two lectures. So we'll start off with the definition of a level curve. A level curve to a function f of xy is a curve given by f of xy equal to k, where k is a constant. In this case, we're trying to take something that is three dimensionals. F of xy has points with an x-coordinate, a y-coordinate, and if you wanted the z-coordinate, you compute f of xy to get the z-coordinate. So the points involved in its graph are three-dimensional. So we take this three-dimensional graph and use level curves to interpret it into a two-dimensional graph. So to give us some insight of what's going on here, let's look at a particular example. Here's an extra one for you. Suppose that we're looking at the function f of xy is equal to x squared plus y squared plus 1. And suppose that we are trying to find the level curves for the values of k equal to 1, k equal to 2, and k equal to 3. All right. So, actually, let's throw 4 in there. I think 4 level curves would probably be a better way to display this. So, to get things started, let me start off with k equal to 2, because that's going to give us something a little bit more tangible to work with. For the level curve when k is equal to 2, so again, we're going to take our function f of xy and set it equal to that k of 2. F of xy is x squared plus y squared plus 1, and I'm setting that equal to 2. And by moving the 1 over, we have x squared plus y squared equal to 1. Now this guy right here is a curve in 2 dimensions on the xy plane. I'm perfectly familiar with that guy. This is just a circle of radius 1. So again, this lives in 2 dimensions on the xy plane. To give us some insight of what this level curve represents, let's look at f of xy. So again, this graph is x squared plus y squared plus 1. And on the xy z coordinate system, this guy is the paraboloid that we graphed in our previous section, plus 1. So you're going to take that paraboloid and shift it up 1 unit. So that graph will look something like this. So again, this purple graph is a graph of x squared plus y squared plus 1. And we're taking that purple graph and we're setting it equal to 2. For that 2, you could think of this as the graph of z equals to 2. This guy will be a plane where the z values are always 2. In 3 dimensions, this will look like the plane that looks like this. And I can ask myself, where do these 2 graphs intersect? And they will intersect about this circle right here. And if we were to take the x's and the y's for the circle and consider what the x's and the y's look like, they'll make up our circle of radius 1. To get a clearer understanding of these graphs, let's take this to GeoGebra 3D. So in GeoGebra 3D, I can graph out my x squared plus y squared plus 1. And that is my paraboloid. And let me graph out z is equal to 2. This guy is my plane. and look at where these guys are intersecting. If we tilt this in just the right way, we see that the x's and y's where these two graphs intersect make up a circle. And when I tilt this graph in just the right way and consider the x's and the y's on the xy plane, this is the graph of a circle of radius 1. Okay, so that is my level curve for k is equal to 2. And we could find the other level curves going through this same kind of analysis. So we started off with k is equal to 2. Let's look at what things look like when we include the 1, the 3, and the 4. For reference on here, I'm going to have the collective of all of the level curves. So far, we've done the level curve for k is equal to 1. Let me say that this is 1, 2, 3, negative 1, negative 2, negative 3, 1, 2, 3, negative 1, negative 2, negative 3. And again, for more work, when your k is equal to 1, we have that level curve. Let's take a look at what the level curves look like for k is equal to, so that was the level curve for k is equal to 2, not for k is equal to 1. Made my mistake. Let's look at the level curve for k equal to 1. So we'll take our f of xy and we'll set that equal to 1. F of xy is x squared plus y squared plus 1, and we're setting that equal to 1. Subtracting 1 from both sides, we have x squared plus y squared equal to 0. And consider what combination of x's and y's you would need to make this 0. The only combination of x, y that you can plug into these two values that will make this 0 is the scenario where x is equal to 0 and y is equal to 0. So the level curve is only made up of 1 point. So on our graph on the right hand side here, here's the point 0, 0, and that guy is the level curve when k is equal to 1. How can we interpret that graphically? Well, again, back to GeoGebra 3D. Again, here is my graph of x squared plus y squared equal to 1. And I'm looking at the level curve when the k is equal to 1. That represents that plane down here. And consider where these two graphs are intersecting. They only intersect down there at that tip. And for this tip down here, this guy has coordinates 0, 0, 1. And if I'm only collecting the x's and the y's for my level curve, then the level curve would just be that point of 0, 0. Okay, so we got the 1 and the 2. Let's look at the level curve when k is equal to 3. So again, set f of xy equal to 3. So we have x squared plus y squared plus 1 is equal to 3. And when you subtract 1 from both sides, you get x squared plus y squared is equal to 2. Now, this is going to be a circle of radius 2. Excuse me, of radius radical 2. Sorry, I was typing things in while I was talking. So again, circle of radius radical 2. And if I pull out my calculator and I compute radical 2, that's approximately 1.41. So taking the circle of radius radical 2 and plugging that into my graph for the collection of the level curves, again, this guy right here is 1, this guy over here is 2, so 1.41 should be about right there. And if I use these 4 points to graph out the level curve, I get something that looks like this. So again, this guy right here is the level curve for k is equal to 3. One more to go. When your k is equal to 4, let's see what that looks like. So again, set your f of xy equal to 4. So x squared plus y squared plus 1 is equal to 4. So x squared plus y squared is equal to 3. So this guy would be a circle of radius 3. Pardon, radical 3. And radical 3 is approximately 1.73 and change. So if I graph out the circle of radius radical 3 up on this graph, again, which is 1.73 and change, I would get something that looks approximately that one went a little too far. Like that. So that's my level curve for k is equal to 4. With this two-dimensional graph, we can get a sense of what's going on with our three-dimensional graph. Notice that if I started a path from this point here, and if I traveled this way, it would take me this long to travel up one whole unit. But if I started here and went in this direction, it will take me that long to travel up one whole unit. By looking at these two paths, I can see that I have to walk a little longer, or not necessarily longer, but it's a longer path from here to here to elevate myself one unit. But from here to here, it's a shorter path to elevate myself by 1 unit. Graphically, in 3 dimensions, you can interpret this as in the following way. This path up here in blue is steeper than the path down here in green. In terms of my graph and the GeoGebra 3D, if you were starting your travels down here and traveling out in any direction, the further you go out from that starting point, you see that the curve is going to become steeper and steeper and steeper and steeper. So the further you try to walk your way out of this bowl, the steeper of a path you're going to encounter. So whenever you're working with these level curves, whenever these level curves are closer to each other, that means that that you're experiencing a steeper path.